Hello. How's everybody doing? Good? A little hungry? Okay, I won't waste too much time. But yes, thank you, JScamp, for having me here today. Today we're going to talk about how we are solving performance for the modern web at Microsoft. And so a little bit about myself. I'm a program manager at Microsoft working on the Microsoft Edge team. I used to spend some time on the dev tools, and then I moved over to developer experience and what we call our ecosystem team. So a majority of the time that I spend every day at Microsoft is working with framework authors, tooling authors, and finding out how can we take best ideas and practices from you and build them into the web platform. But you all may know me here as one of the maintainers of an open source project called Webpack. How many here today are using Webpack, right? Whether you like it or not? Okay. And I'm also here representing, I also represent Microsoft at the Node, or on the modules group for Node.js, as well as the W3C working group for WebAssembly. A little bit about myself is that I'm a former tech support rep gone rogue. I got tired of not being able to solve people's problems. I mean, in school, I was actually a music major. So I learned how to program, started with Ruby and Objective-C, and then finally moved to JavaScript, and I really fell in love. You can find me anywhere on the internet, with @thelarkin. So feel free to add me on Twitter. My DMs are open. You can ask me questions anytime you want. So web performance. There are so many different, people are going to throw on web performance all day. And, there's always that one talk at a conference who has to bring it up. Who here at work has, goals or, metrics that they have to hit for web performance? I was expecting a few more hands, but don't worry. So us at Microsoft, every single one of our web teams has what we call one OKR that we have to meet for web performance. And so throughout Microsoft, this is an extremely important metric that we have to meet. But I'm not just talking about how deep are our React render stacks, right? I'm not talking about scroll jank or 60 frames per second in our paints. I'm talking about interactivity. And I could talk about interactivity, or I could just show you what it's like to experience terrible interactivity on a website. It doesn't matter if your application is server-side rendered. If you still have JavaScript on your page, which is blocking the main thread, you're not going to be able to interact with the website whatsoever. And on average, most websites take 17 to 20 seconds to get interactive. And so it's extremely frustrating for users. And these two examples here are applications that not only depend on, well, one of them depends on Webpack, but have entire performance teams. So performance issues and interactivity issues are still prolific in our ecosystem. And really what I'm talking about here is an initial page load. And most times you can break open your dev tools, you can do a profile, and really it's going to categorize what took the longest to process in our application. And if you can see here, a lot of it's JavaScript. And a lot of times people say Sean, why does this matter, right? And I like to throw these statistics out first, right? So the average website today takes 19 seconds to get interactive. But if you're able to reduce that to, let's say, 5, the differences are huge. CTOs and dev leads, open up, your eyes here. 60% greater page views, 35% lower bounce rates, 70% longer sessions, and 25% higher visibility in SEO. Might I mention, 2x greater mobile ad revenue, 200%. So this is not just, we're not doing it to feel good. It's really important to us. And so what I'm going to teach you is, what are the top 3 main causes of delay in interactivity or load time? So the first, you might have guessed, it's JavaScript. Did you know that JavaScript is the most expensive resource to parse on a browser? Not only does it have to receive it from the network, it has to parse, evaluate, and then execute it. And it's thread blocking and what we call CPU bound. And then next is the amount of CSS that shipped for the initial download. And finally, at a distant third, the amount of network requests that you receive on the initial download. So I'm going to show you some benchmarks, but I don't want you to run away when you see them. At Microsoft, we have two different types of goals, right? One, you could say, how fast does this work on airplane Wi-Fi? Or how fast does this work for an intranet website? Everybody is going to have different performance web goals, but the point is that you have something that you try to reach, and you increment towards it. So for this airplane Wi-Fi, we say, we want to get to 200 kilobytes uncompressed for the initial JavaScript. And this also, works for people who are in emerging markets, let's say using 2G devices or 3G devices. And they rely on mobile to be able to access the web. And then next, for CSS, we try and say, let's get to about 100 kilobytes uncompressed of initial CSS. And then finally, for HTTP, you want to have about 6 or 7 concurrent network requests, but with H2, you can do anywhere from 20 to about 30 or 40. And then finally, there's a metric here that I'm going to talk about, which is code coverage. 90% of the code coverage is what we kind of strive for, but you might be like, what does that even mean? And I'll show you how you can actually measure code coverage. So if we go to any website, why don't we just use JScamp? No worries, no worries. It's a very nice loading site. David's sweating over here in the background like, oh no. So so I'm using Microsoft Edge here, the newest version, and if you open up Microsoft Edge DevTools, you can hit Command-Shift-P or Control-Shift-P and type coverage. So this will open up a panel down here that's called the Coverage tab. And if I hit the Reload button, what this is going to display is all the JavaScript and CSS that was necessary for this page to become interactive, right? And so you can see here that it says 103 out of 160 kilobytes was actually not used for the initial loading of this page, right? So the question is, if JavaScript is the most expensive resource and causes the slowdown in our applications to load, why are we shipping unused code? So how do we go about remedying this problem? And you might know, because I had the slide up next, but there's this technique called code splitting. Who here knows what code splitting is? Okay. Oh, wow! That's good. That makes me really happy. So I tried to find like this really intimate definition, right? Like, what does code splitting mean? And I only came across like our version 1 docs of code splitting from Webpack. So I'm not going to share that with you. But who's ever used Google Web Toolkit? Anybody here know what Google Web Toolkit is? Okay. So Google created this framework that allowed you to take Java and compile it into JavaScript. What could go wrong? But, hey, they did invent something that was really special, which is this concept of code splitting. So by having this function called gwt.runAsync, it allowed developers to basically define where they would create lazy loaded bundles of JavaScript. And so anything that's defined inside this gwt.runAsync, it would compile this Java code into a separate JavaScript bundle that would only be loaded on demand. And then along came Webpack in 2012 as a side project for a person named Tobias Koppers was working on his master's thesis at the time. He decided to fork an existing bundler that did not have code splitting in it. And you can always ask me later, but this is why Webpack exists today, to implement code splitting. And so we kind of define it as the process of splitting pieces of your application into asynchronous chunks, right, at build time. And I think that's something that's really, really, really important, right? If you're not able to do this as a build step and get these lazy loaded bundles, you're going to have a really hard time negating some of the trade-offs of using code splitting. So how does it work? There's two types. One is I'm just going to call static, and then the other one we call dynamic. And I put really heavy quotes around it because everything that Webpack does is dynamic. Or I'm sorry, everything that Webpack does is static. So when would you use this technique? Heavy JavaScript, right? You have that really huge library that you don't need right away. Perfect candidate for code splitting. Anything temporal. So when I say temporal, like, is it not visible at first? And then does it become visible? That's a perfect example for when you would want to use code splitting. Tooltips, pop-ups, modals. Anytime a user clicks on an input or interacts, that's going to be when you can respond with code splitting. And then finally, routes, right? Who has a client-side router, right? Like probably half the people using a framework use a client-side router. How many routes is a user on at one time? One, right? So every other route can be code split. So here's a really simple example that tries to kind of showcase what code splitting is. The first thing that we have here is a listener that's statically imported, right? Now, anything that any bundler works this way. So it's not just Webpack. Rollup does the same thing. So if you see a static import, it's going to automatically put this into your initial bundle, right? But you can see here, we also have a function that's defined that returns a dynamic import. If you're not familiar with the dynamic import statement, this allows you to dynamically fetch a module in the browser and load it. Before the syntax existed for the browser, you'd have to perform a fetch or an AJAX request, and then you'd have to eval the string of JavaScript, and then it has to work inside of your code system, and it was really messy, right? So the browser implemented this dynamic import, and now Webpack has adopted this, and other bundlers have adopted this as the way to define when code splitting occurs. So you can see here, when an event triggers, we decide to call this function, and by default, it converts it into a promise behind the scenes, right? So once this promise is resolved, we can access the module as if we've statically imported it. But the huge difference here is that instead of it landing in your initial bundle, this is going to be separated into a different JavaScript file. And most importantly, it removes it from the initial size of your bundle, right? So we're now being able to remove code that's not needed up front. And then finally, we have this concept, which is dynamic. Dynamic. So you can see here that instead of just using a dynamic import with a static string, we've also added an expression inside of it. Now, as long as there's a partial path, this allows us to be able to call specific examples based on runtime conditions. And this is kind of powerful, right? Because now we're able to actually access or load different bundles lazily based on a user's input, or as I said, runtime conditions. And I was like, what? And I'll break this down for a second. I'll break it down for a moment so that we understand, right? So the most important piece here is that you have this partial path, right? Because it's going to tell Webpack, hey, for all the modules that are inside of this particular directory, I need you to create an individual JavaScript bundle for every single one. But don't load them up front, only load them on demand. And there's a lot of great applications or use cases for this, right? A/B testing. Like anytime you're doing A/B testing, how many tests is a user on? One, right? So why load both tests? That's a waste of JavaScript. Or an expensive, you only have so much of your budget to spend, right? Theming, right? So anytime that you want to switch up a theme dynamically, this is a great alternative. Or just convenience, right? So we could implement these other, I could have implemented this with just static imports, right? But it would be this long switch statement, and it would be kind of a pain. So it's also just a nice convenience feature for developers. Okay, Sean, cool. I've heard you talk about code splitting. Let's see a real-world example. So one of the coolest parts about my job is that I get to go spend time with a bunch of web teams at Microsoft, and we do these things called performance clubs or perf evaluations. And so a team reached out one time, and now to be able to make my impact scale, right? I've created a kind of a format for any time that I'm doing these performance evaluations, right? Now, this isn't a public website yet because we're still working on figuring out where we're going to have it and legal and making sure that all the source code can be shared. But I have permission to share with you some of the content that's inside of it. So I worked with a team that's called config.office.com. And you might ask, what is config.office.com? Now, I'm not going to try and read this completely, but long story short, if you use Office, who uses Office, right? Okay, so there's an IT admin out there for your company who literally has to install this on your computers, right? And they need to support a variety of languages and locales and everything. And so there's somebody out there who has to use a website to then get these binaries and deploy it to computers. And that's exactly what this website does. And so we needed to have a methodology to be able to actually ship this, or to do performance clubs. So I took one from a friend named Paul.
I like that. That's good. Like you measure, you profile,
Yeah.
you diagnose. It's like MIPTIA.
It's like MIPTIA?
MIPTIA.
It's what MIPTIA?
MIPTIA. You measure, you profile, you diagnose, you identify, and you attempt.
Oh, you're making an acronym of that.
MIPTIA. 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 It's the new framework for performance diagnosis. There was Rail, and that was cool, but that's so like 2015.
Sure.
MIPTIA is so 2016.
Yeah, totally.
Right? Like you just see MIPTIA.
No.
Like people are shouting, and I hear it. Really?
Right, so thank you, Paul Irish and Sam Ciccone from Google. They thought that this was satire, but I took it to heart, right? Because you really do need a process and a cycle so that you can use when you're evaluating people's websites. So you can see in the sidebar here that everything is spelled out by MIPTIA. And you should have your own system. It doesn't have to be exactly MIPTIA, but use something yourself. And so, this team reached out initially because they wanted to upgrade to Webpack 4. And, the first question is like, why do you want to update? Well, we heard there's some better tree shake. And I said, well, why are you concerned about that? Well, we were worried that our performance of our application was slow. And so we did an initial profile, right? And we found that on a really nice Microsoft broadband website, or internet connection, it took 4 seconds for this page to become interactive, right? That raised some huge red flags. Even some large JavaScript payloads don't even take 4 seconds to parse and evaluate. And then we took a look at the code coverage. So the coverage tool that I showed you, I use as part of this step. So understanding, profiling the primary cost. And we found that out of 18.8 megabytes of JavaScript, only 18.2 was actually used. So that's 79% of the code was wasted. However, contributing towards the slowness of the page because it still has to be parsed. So when we took a dive inside, we looked at the line-by-line examples of what was being used and what wasn't. We found something that really was pointing red flags. So all of the locales that were needed to support localization for this application was included in these initial bundles, right? And so when we looked at the source code, this kind of verified it for us, right? So we know that Webpack, if it sees a static import, it's going to take and put any resource in the initial bundle. So here you can see that every single locale was imported by default, right? And this would be okay if it wasn't included in your initial bundle, but it turns out it is, right? And there was a giant switch case that just basically said assign based on the locale. Great. Now, what was nice or surprising, but also surprising to me was the component that called this class or function. It actually had a visibility state of hidden by default. So it's not even like this information was needed up front. It wasn't even needed until a user interacted with the page, right? Expanded the dropdown and made this component visible. So here's a huge area of opportunity for us to kind of dive into. So if we diagnose the unoptimized behavior, we could say that the amount of JavaScript this page was shipping was really the primary cost, right? Since it's the most expensive resource to load, it was really peculiar to see 97% unused. And so I don't really like dwelling on root cause too much because it only is sometimes it turns into finger pointing. But, these reports end up going to my boss and my boss's boss and my boss's boss. And so they need kind of an explanation of the tooling and the systems that are being used, right? So the build system is Webpack, right? Webpack's the third most used open source project at Microsoft, and they depend on it heavily. But kind of a pitfall, wait, what? The root cause is Webpack? Uh-oh. What? No, you could say, yeah, bundlers. But at the same time, I think, you can see here, I explained that when people use the static import, automatically code gets added to your initial bundles, right? Even if it's not used. So It's super easy for engineers who don't have background, in front end or build tools or anything to be able to just automatically, statically import everything, right? And so it's not just something that, everyday developers do. It's, even the greatest software engineers who've been, working on, other platforms for a long time can easily make these mistakes. So what's the root cause? It's the engineer's fault, not the tools. No, I think this is just a matter of better education. But enough finger pointing. When we dive into how we fix this, code splitting is the perfect answer, right? We have all this code that's not needed. We have a way to actually, we have a syntax that will allow us to lazy load this information. And so looking at a one-liner, it would be replacing this static import with a dynamic one. But we want to make this more convenient, right? Because we don't want 200 of these dynamic imports. So we're going to use dynamic code splitting. So you can see here, we have this function called getLanguageJSON, right? And it allows us to pass in multiple parameters, and Webpack will automatically look for every possible module that exists inside of this path, right? And so therefore, all we have to do is call this function multiple times for each product type, and it reduced the size of this file from like 350 lines to 65, right? Not only did it do that, but it removed 16 megabytes of JavaScript from the initial bundle. And you'll see when we look at the before and after profiles. And some people might say, well, Sean, if you lazy load everything, isn't there going to be some sort of effect? Users now have to wait for the network. You're right. But because Webpack is a tool that works statically at build time, we can negate this network cost by using techniques like service workers. Who uses service workers today? So what's really awesome is that service workers, you don't have to know the whole API, but you can still leverage it to get a feature like this, which is like asset pre-caching. There are two plugins that we use at Microsoft and we heavily endorse. One is the Workbox plugin, which is made by, I think, Google, and then the Offline plugin, which is by a contributor to the Webpack organization. Now, just simply by using these plugins, it's as easy as automatically pre-caching all of your assets without even needing to know anything else about a service worker. So when we took a look at the before and after, you can see that this is staggering, right? So not only did we remove 16 megabytes of JavaScript from the initial bundle of this application, we also cut the interactivity time by a factor of 4, right? And even a factor of 2 for latent networks. That's huge. You might be like, Sean, why should I care? Right? The future of the web is mobile, right? The average website takes about 14 to 20 seconds to get interactive. And the less JavaScript that we're shipping up front, the faster we get interactive. And WebPerf, for us, it's not just for fun, right? There's serious high-impact return on investment. And so, in addition to code splitting, there's a whole bunch of other tools that you can leverage that we built at Microsoft. So one, which is to prevent cross-tool pitfalls, we love suggesting webhint. So the Microsoft Edge team built this tool. It's similar to Lighthouse, but what makes it different or separates it from Lighthouse is the ability to not only be configurable, but it doesn't have a one-size-fits-all kind of mentality about performance. Not everybody is trying to build their application to be fast on, airplane Wi-Fi. And so this not only allows you to configure and set guardrails for whatever performance you're trying to meet, but it also allows you to be able to identify specific scenarios for your dev environment. So some of the things that I saw most prolific at Microsoft were that people would just have TypeScript or Babel set up wrong, and their application bundle size would be 50% larger. And so what is awesome about WebHint is I worked with that team to make sure that now they have checks that run in your dev environment that says hey, you're configuring, you have source maps turned on in your production environment. Or hey, you're not using the right module format for Babel or TypeScript. And so this is an awesome tool. Or you can take a look and identify and track per build, like the Mixer team does. They built this Webpack Bundle Compare. It's very similar to our Bundle Analyzer, but it also allows you to track the delta between your builds. and then identify like what was the cause, why did this, what module made this this bundle that much larger. In addition, we have GitHub bots that we use on Office UI Fabric, which is called the size auditor. And so I made a PR one time to Fabric because I noticed a performance gotcha. And you can see here, we can validate all the changes that we make based on this bot's feedback, right? So I reduced the size of a bunch of components by X amount. And this is open source, so you can go and use this too for your component libraries, for your web applications. And then there's also smaller techniques like minimizing your use of state or the cost of your state. So does anybody use like Redux, right? Probably a couple, yeah, if you're using React application. So the Mixer team created what's called the Redux Dynamic Modules. And this is also an open source project on the Microsoft GitHub. And this allows you to dynamically declare a module and lazy load it into your application. So if you have a bunch of state that's not needed until a user gets to a different route, then this code allows you to kind of avoid the boilerplate and being able to manage this and makes it easy to lazy load any pieces of your store. But like I said, have a system, right? Just make a system and iterate over that so that you can have a consistent web application and making performance a first-class citizen, whether it be through your CI or the practices that you do every day. And whether you realize it or not, you could become Microsoft Fast too. So thank you very much.